Hello all, welcome back to my channel. Thank you for your support and for watching all of these videos. In this video, let's take a look at feature importance and why it is required. In the previous video, we have seen the correlations analysis between columns, and here we will take a data set, we'll split the data, we will train a model, and then we will we will do the feature importance and to see like which columns are really contributing and which ones are not contributing. So until now we have seen the random forest classifier, and in this one we will take the decision tree classifier. Okay, so let's select all the data cells, let's delete this one, let's copy the data, copy the dataset file. Okay, import pandas. I hope this is clear. This is as pd df is equal to pd dot. This is a CSV file, so read CSV. Okay, low memory is equal to false. I wanted all the memory. I don't want the low memory. So I already did the explore data analysis on this one. So I'm not going to do this one. So all of these columns until here, I'm going to assign as x. So x is equal to df dot drop. Columns is equal to this one. Axis is equal to 1. Y is equal to df of target. So x of 2, y of 2. Okay, this is fine. Let's split the data from sklearn dot model selection, import train test split, import numpy as np dot random dot seed. So more than theoretical, I would like to interested to go everything with the code. Believe me guys, as long as you are proficient, you get expertise in this code, you would be doing fine. So people do say that you have to learn the theoretical part and all, and yeah, once you become comfortable, I don't deny that once you become more comfortable with the coding part, you can focus on theoretical part. So why you need the theoretical part? If you would like to design a new ML model, like how the existing ML models are there, then you need the theoretical statistics part as well. I'm not really good at the statistics, but I'm comfortable in terms of developing the models. So FYI, so not everyone is really good at everything, so you have it. So let's take ML model. So instead of taking the same model, let's take sklearn.tree, import decision tree classifier. Okay, I'm calling call DTC is equal to decision tree classifier. Okay, so DTC dot fit x train y train. Okay, this is done. DTC dot score, let's see how well it is performing on x train y train, and DTC dot score x test y test. Okay, this is not that great, but it is 70% of accuracy. Okay, and now let's do the predictions. Y predictions is equal to DTC dot predict x test, and these are the Y prediction values. And if you want to see the original values, np dot array y test. So these are the values. Okay, so now let's do the feature importance. What is the feature importance? So what are the features? Features are nothing but all the columns which are here. These are the features. Now, do you really think all of these are really helpful? Take a minute, maybe or may not be, and we really don't know which columns are really helping us to predict the right values and which columns are really not. So just assume that what will happen if you don't remove the dimension reduction, if you don't do the dimension reductionality, or like if you have like more dimensions, more features, if you don't remove, what will happen? Nothing will happen. But in our case, there are like some 14 columns, but assume that if you have like some 1400 columns, and if you're running that, even if you have a memory of like RAM memory of 256 GB, it will not be sufficient for you guys. Just assume if you have a data set of 256 columns or 500 columns, 1,000 columns, and a data set of like 1 million records, even 256 GB RAM is not sufficient. I still remember that when I'm doing my first model in the production. So I had a system where the RAM is like 256 GB, and I was still not able to train my model. It's because I was I had lack of knowledge that I have to do this dimension directionality. And how I can do, we can just remove like trial and error, like, let's remove age, let's remove FBS. No, it's not like that. There should be some reason behind that. So that is called feature importance. Okay, so let's do this one. DTC dot DTC is the model, right? We already trained the model. Feature importances. Okay, so this has given some values. For example, for age, it is contributing 0.06, and this one, it is contributing 0.065. For example, you see this one 0.08. This is contributing more. So let's let's say, okay, I myself not sure what will happen if you sum all of this one. Okay, let it be. Okay, so but I wanted this to be in data frame. PD dot data frame data is equal to DTC dot feature importances. If I run this one, so it is giving something, but what is the name? What is I want the names, right? So index is equal to x dot columns, the column names. So if you say x dot columns, it will give all the column names here. So x dot columns. Okay, now if we see here, it is giving some numbers with respect to each and every input column or the feature. And let me save this as feature importances. Features. Okay, so let's plot a graph and see like graphically, which is this one. So features dot plot kind is equal to bar. Okay, I don't want this to be here, so legend is equal to false. Plot dot show. So here, if you see this one, out of all this, so CP, this is performing better, and age is okay. This one is okay. And if you look at FPS, REST ECG, EXAGNG, these three ones actually they are contributing very less. So what we can do when we are training the model, x is equal to df dot. So these are the values, right? So these are the original values of the data set. So what I'm going to do, I don't need all of this one. So I will remove this one. So let's do it again. X is equal to df dot drop columns is equal to this one target. Okay, axis is equal to 1, and this is how we split the data, right? Df of target. So now along with the target, I want to remove fps. I will remove this one here, and then what else is not performing? Rest this one. Okay, I'm removing this one. And then this exang, this also I don't need. So why? Because of doing this, your model size also will be less. It really helps you to deploy the model very fast, or else it takes lots of time. So now if you see x of this one, okay, y of this one, you can see that we have deleted few values here. Now let's split the data. X train, x test, y train, y test is equal to train test split of x y test. Test size 0.2, a random state 42, stratify is equal to y. Right, let's quickly see the shape. This is very much important, guys. I'm telling you with some experience. X test dot shape, y test dot shape. Okay, now DTC is equal to decision tree classifier, right? So DTC dot fit x train y train. Okay, and now let's DTC dot score x test y test. Let's see the score. See, the score is like 78% this time, because we have reduced the unwanted this one, and still it is performing well. So this is how you have to understand what all the feature importance. If you remove the CP, let's look at this one. So here let's remove the CP. It is the most performing one over here. Okay, let's remove the CP and let's do it again. I'm running everything again. I have removed the just pen type. Okay, and see, the accuracy dipped like anything. So this is something that you always have to remember, like what do you have and what columns that you should go ahead with that. And this also comes under the data exploratory analysis guy, so do remember this one as well. Thank you for watching this video.